Implicit differentiation. We use implicit differentiation for relations that do not explicitly express y as a function of x. For example, x squared plus y squared equals 1, or x cubed plus y cubed equals 6xy, do not have y written as a function of x. When this is the case, we have to use implicit differentiation, and we use it as follows. We first take the derivative of both sides of the equation with respect to x, and we indicate this by using d divided by dx. Each time we take a derivative of y, we will attach a dy dx to the end of that derivative. Then we solve for dy dx, that is, we want to get dy dx alone on one side of the equation. Example 1, we're asked to find the derivative of x squared plus y squared equals 1. Because y is not expressed as a function of x, we use implicit differentiation. We start by indicating that we're taking the derivative of both sides of the equation with respect to x. Then we take derivatives. The derivative of x squared is 2x, and the derivative of y squared is 2y, but because y is not x, I attach a dy dx to indicate that I'm taking the derivative of y with respect to x. On the right side, the derivative of 1 is 0. Now I'll need to solve for dy dx. I start by subtracting 2x from both sides, then dividing both sides of the equation by 2y, and I get that dy dx is equal to negative x divided by y. Example 2, I want to find the derivative of 8xy minus 1 is equal to y cubed minus x. Again, y is not written as a function of x, and therefore I use implicit differentiation to find the derivative. I start by indicating that I'm taking the derivative of both sides of the equation with respect to x. Over on the left, 8xy requires the product rule. Product rule says the first function times the derivative of the second, plus the second function times the derivative of the first, minus the derivative of 1 is 0. On the right, the derivative of y to the third power is 3y squared, but I have to attach dy dx because y is not x, and the derivative of minus x is minus 1. I continue taking derivatives. 8 times the derivative of y, well, the derivative of y is 1, but I must attach dy dx because y is not x, plus y times the derivative of 8x is 8, and the right side remains unchanged. Now I'll solve for dy dx. I have 8x dy dx plus 8y is equal to 3y squared dy dx minus 1. Well, I'll get my terms with dy dx on the left side and terms without dy dx on the right. So I have 8x dy dx minus 3y squared dy dx is equal to negative 1 minus 8y. Because my two terms on the left both have dy dx in common, I'll factor it out. And then to get dy dx by itself, I'll need to divide by 8x minus 3y squared. So my final answer for the derivative is negative 1 minus 8y divided by 8x minus 3y to the second power.